Maybe.
Okay. Good morning, good afternoon, good evening, everyone. My name is Jason Walls from QA Cafe and the Purple Marketing Committee. For the next in our installment of webinars that we've been doing this year, try to do one every couple months, about once a quarter. But we had the right people in the right time to give everybody an update on how you can build Wi-Fi extenders using using prplWare. And to present that, I have Nikolai Popenkov from Inango, along with a couple of his other colleagues who can help answer questions at the end, who is going to go through the whole thing and kind of how we got here, what features are available right now, how to do it, and then a little bit of a live demo to see how it works, which is pretty cool. We are using Zoom for this webinar, obviously, so if you do have questions, please ask them at any time, and if they're super relevant to whatever Nicola is talking about at the time, I'll try to jump in. But please do use the Q&A control panel to do that, because it'll help us all see the questions equally, and then we'll get to the majority of them at the end. If any time during this you find something hard to see, you can, I believe still, there is a Zoom control in your Zoom panel that lets you zoom in on what it is that you're seeing. So feel free to use that. Otherwise, I will hand things off to Nikolai and come back in at the end. We stop sharing. Nikolai, go ahead.
Yeah, hi all. Let me share my screen. Yes, can you see?
Yes, indeed.
Yeah, okay. Hi all again. Good morning, good day, good evening, depending on where you are. My name is Nikolai Popenkov, and I'm Architecture Group Manager at Inango. We're proud to be part of Purple community. We have been working in the mesh domain for several years in Purple, and recently we became more active in development of core prplOS features, such as the extender, which is the focus of today's webinar. Extender has many aspects that we would like to cover today. For example, from home users' point of view, aspects from operators' point of view, technical details of integration with existing systems, configuration, provisioning, details of prplMesh configuration, and more and more and more. But given a limited time today for the webinar, I'll try to pack as much information as possible, leaving some time for question and answers section. Okay, so the first slide. I would like to start with a short overview of prplWare. prplWare is an open source suite developed by Purple Foundation. It consists of several components. prplOS is open source software stack for home services. prplMesh is, again, open source implementation of Wi-Fi mesh networks. High-level API. It is a layer that standardizes communication with the operator. prplLCM is implementation of application lifecycle management. And finally, Purple low-level API is the layer that standardizes access to services provided by Linux-based operating system. prplWare ecosystem. prplWare gives a full-featured ecosystem to build and manage Wi-Fi mesh networks. And let's see what the elements are. prplOS gateway, prplMesh. prplMesh, it has two sides, controller and agent. And for the prplMesh controller, we have suitable CPE to run controller on. This is the prplOS gateway. The next element here is remote management protocols. In Purple, we have a choice. We can use either TR69 or USP, with USP being the ultimate goal. And also we have, as one of the element, TR181 data model with objects to manage Wi-Fi, device Wi-Fi data elements. So these are 4 elements of prplWare ecosystem to build and manage mesh networks. But till now, the 5th element was missed. And the 5th element is the extender CPE to run a standalone prplMesh agent node. So what is Purple Extender? It is a specialized prplOS build profile for CPE devices intended to run prplMesh agent node. We can also say Extender is a lightweight version of prplOS with the minimal set of packages and services in order to reduce flash and memory footprints. There is no WAN and gateway functionality, and all services are limited to LAN only. For example, DHCP client. Services that are excluded from the extender. DHCP servers, both v4 and v6. Point-to-point manager, WAN manager, because there is no such conception as WAN interface in the extender. And also there is no web interface and other services. But still, extender, it's based on prplOS and it's still managed using high-level API. Of course, except for data model of excluded components. And at this point, I would like to emphasize that Purple Extender is not a dumb Wi-Fi repeater. As its name, Extender may suggest, it's a part of intelligent Wi-Fi mesh network with a centralized controller. Thanks to prplMesh agent that runs on the extender CPE and turns it into a full-featured mesh node. A few words about extender product features. Zero-touch provisioning. This is like a plug-and-play approach. There is nothing a home user should or may configure, except maybe of connecting a cable between extender and gateway, or pressing WPS push button on gateway and extender. All configurations for the extender, if needed, is passed by a gateway via DHCP. It is a responsibility of the operator to supply the gateway's DHCP server with proper configuration, and we'll explore this shortly. prplMesh agent. Extender does not introduce and does not add any new prplMesh features. It just lets the prplMesh agent to show and express all its functionality as the mesh agent node, namely onboarding, auto-synchronization of settings, WPS push button, traffic separation, steering, and so on. Manageability via TR69 or USB. As well as gateway, extender can be managed via using TR69 or USB protocols if needed. And the first question here is, because we already said about the zero-touch provisioning, and the first question here is how to configure ACS or USB controller URL for TR69 and USB agent to connect to ACS or USB controller. And the answer is, again, because of zero-touch provisioning, all needed configurations are provided by DHCP. And we'll explore this in more details shortly. Also, extender includes ready-to-use prplLCM agent to install and manage applications. I'll cover this feature in slightly more details later. Loop detection and avoidance. Though loops don't happen often in home networks, but extender has a loop detection capability, and if a loop is detected, extender disables its port that causes a loop by using STP protocol. And the last point here, for users' convenience, if extender is going to be connected to the gateway controller using a cable, there is no dedicated Ethernet port in the extender device for gateway controller. A user can connect Ethernet cable to any Ethernet port of the extender. Okay. Purple extender profile comes in two flavors. The first one, minimal flavor or minimal profile. This is just the very basic flavor. It is carefully stripped down prplOS, no WAN services. It includes prplMesh agent, loop detection, and we can call this unmanaged extender because there is no TR69 agent and no USB agent. The primary goal of this flavor is to offer extender with the most minimal footprint, and also if management feature is not required, and if LCM is not required. And also we provide full flavor. It is a still carefully stripped down prplOS version. It has everything that minimal flavor has, plus TR69 and the USB agent, and plus LCM agent. This is managed extender. Actually, the flavors are implemented as a regular Purple build profiles, and the exact flavor, minimal or full, is selected at build time. I want to highlight it one more time. This selection happens not in boot time and not in runtime, this selection should be made in build time, during build time. So to build extender flavor, you use regular prpl build commands. Just need to select build profile you need, either full or minimal. Okay, if you need, yeah. And then you can just start a build using make command as usual. Small note here, extender profile is platform agnostic. It has no platform dependent code. At Inango, we developed and tested extender profile on Freedom platform. Though we didn't test it on other prpl supported platforms, we believe it should be a problem to run the extender on other platforms. Okay, go on. prpl extender and home network. prpl extender device must have a connection to the gateway controller. And the connection can be wired using Ethernet cable or wireless, initiated by WPS push button, so-called prplMesh backhauls. On this picture, the left side prpl extender, as we can see, it's connected to the gateway using wired backhaul, and the right side extender connected to the gateway using it uses wireless backhaul to connect to gateway and controller. Extender can also be connected to another extender. This is called daisy chaining, and extender and again extender can be connected to another extender using either wired or wireless backhaul. After being connected, extender acquires its IP address by DHCP. This is a part of zero-touch provisioning. Extender has out-of-the-box DHCP v4 and the DHCP v6 clients. So depending on gateway's DHCP server configuration, extender may have IPv4 or IPv6 or both addresses. And Slack is also supported. All Ethernet ports and Wi-Fi of the extender device are bridged, and all of them share the same single broadcast domain. So any user's device, smartphone, laptops, as you can see on this schema, smartphones, two smartphones, one laptop and PC, they can be connected to directly to the extender, and they become usual and they become regular LAN hosts, as if they directly connected to the gateway. And they receive IP address from DHCP, from the gateway by DHCP. Users' devices can be connected to extender either using cable or wireless with connection to front hall access point. Because extender behaves like a layer to bridge, it also provides loop detection using STP to prevent home network service disruption due to, for example, if we accidentally connect two extenders. On this schema, for example, if we accidentally connect two extenders from left side and from right side using cable, we have a loop. And in this case, thanks to STP, extender will disable one of its ports to stop the loop, to terminate the loop. Okay, extender management overview. In full extender profile, TR69 and USB agents are included, are both included. And both agents have no pre-configured URLs to connect to ACS and to USB controller. These URLs are provisioned using DHCP options as specified in TR69 and USB specifications. Though extender does not impose any restrictions on that, and it is possible to provision both agents at the same time. It is expected that only one agent will be provisioned at a time, TR69 or USB, but not both. To support extenders management, a few new components were developed. These components are shown in green in this schema. Now let's see how DHCP how DHCP should be configured. For example, to provide ACS URL to the extender. On the gateway side, you need to configure DHCP server to provide a specific value for DHCP option 125. This option and its value will be sent by DHCP server to DHCP client that requests it. The extender profile already pre-configured to make such DHCP requests that ask for DHCP option 125. This value, as we can see here, is a long hexadecimal string. Its content is described in TR69 and USB specification, and how it's encoded is specified, is described in DHCP RFC. Unfortunately, TR181 data model does not provide a convenient way to set such options. So one need to build this string manually. And this is example how this ACS URL is this ACL. Oh, sorry. How this ACS URL is encoded in this value. Okay, move on. TR69 management. DHCP provisioning of TR69 agent in extender is implemented exactly as described as defined in TR69 specification, section 3.1, ACS discovery. The new component, it is shown in green in this schema. The new component, ACS discovery, it looks for received DHCP option 125. This option is sent by DHCP server. It decodes the value, and if it contains ACS URL, this component sets management URL for TR69 agent. After that, the agent can establish connection to the ACS. Because extender is located in LAN behind the gateway, it is not directly accessible by ACS. And to make ACS connection requests from ACS possible, the extender uses a UPnP IGD framework. Yeah. it is assumed that this framework is up and running on the gateway. Extender uses UPnP IGD framework to create a port mapping on the gateway's WAN interface, and thus allow ACS connection requests to reach extender. This is implemented by a new component, HTTP connection request, as shown here. It is implemented according to TR69 specification, Appendix 4. This feature, connection requests, is fully optional, and it can be disabled at build time if not needed. USP management. DHCP provisioning of USP agent in extender is implemented as described in USP specification in section 3.3. The new component USP discovery looks for received DHCP options 125, exactly the same as it works for TR69 agent. And then it decodes this value, and if it contains MTP configuration, it sets parameters for USB agent. After that, the USB agent can establish a connection to USB controller. Important note here, with this node, only WebSocket MTP can be configured. This is because other MTPs, like MQTT, STOMP, they have required parameters that are not described in USB specification, how to provision them via DHCP. These required parameters, for example, this is a MQTT topic and STOMP destination. We have an open ticket in BBF to update the USB specification to allow passing additional options via DHCP, to allow DHCP configuration of MQTT and STOMP MTPs. To summarize here, via DHCP, extender can only be provisioned to access USB controller using WebSocket protocol. But we added, for extender, we added the build time configuration options to pre-configure USB agent with controller URL and other required parameters for MQTT and STOMP protocols. So if you have to use MQTT or STOMP protocols for the extender, you still have a choice here. It's not DHCP provisioning, but it's still possible. Device gateway association. To conform with TR69 specification, extender follows the procedures defined in Annex F, Device Gateway Association 2, that allows ACS to find out identity of gateway through which the extender is connected. Sometimes this information can be very useful for an operator. And also extender implements device gateway association counterpart for USB agent. Again, this is according to USB specification. LCM agent. Purple LCM agent is supported natively in extender, but only in full flavor only. Standard data model device software modules is provided to install and manage applications. There's no difference. There's no difference between LCM in extender and prplOS gateway. except for in extender, installable applications cannot use network isolation. Installable applications may use extender main network namespace if they need network access. Okay, and oh, no. And the final slide. This comparison table of RAM and flash footprints. We collected this data on Freedom Board. As we can see here, minimal extender profile, it uses approximately 100 megabytes less RAM than gateway, which is almost 16% less. And minimal extender profile has 6.5 megabytes less rootfs than the gateway. Okay, this is about 17% less. Purple extender full profile, yeah, it still uses less footprint for memory and flash than the gateway, but yeah, it's somewhat bigger than minimal extender profile. So this is the final slide. And now I believe we have several minutes left before question and answer sections. And I want to show some practical examples. Yeah. Yeah. This terminal in the bottom left corner, this is extender. The terminal in the top left corner, this is the gateway controller. And this terminal in the top right corner, this is the Wi-Fi client. This extender is connected to this gateway. And as we talked, extender, this is the same prplOS, just carefully minimized. And of course, it still has BA-CLI utility to explore high-level API. And let's explore some objects. Okay. I want to show here. I want to show a few things that we were talking about in slides. At first, let's see that the extender has only one IP interface because it acts as a LAN host, and there is no WAN and no routing functionality. So device IP interface. Yes, okay. Except for loopback, we have only one IP interface. This is a LAN interface. And this interface has IPv for address. Sorry. Yeah. IPv4 address. It has one IPv4 address. No, okay. Something went wrong here. Okay, probably. Give me 1 minute. I try to renew. Yes, client one. Yes, renew. Okay, and let's see again. Oh no, so sorry. Of course, we need to see here IPv4 address. IPv4 address. Yep, primary. Yes, we have IP address received by DHCP from the gateway. Okay, and next thing I want to show here is that extender has the only one bridge that contains all Ethernet and Wi-Fi interfaces. Device bridging bridge. Yes, we have only one bridge. Yep. And port. Yes, we have in this bridge we have all network interfaces. Okay, now let's connect. I want to show how to connect Wi-Fi client to this extender and see how it receives IP address by DHCP from the gateway. At first, let's ensure that there is no active Wi-Fi connections to the extender. Yes, this extender is provisioned by prplMesh. It has configured Wi-Fi. So yes, now we see that there is no active associated device with this extender. Yes, and we have here we have 0 active devices. Now let's connect this Wi-Fi client to the extender. Yes, connected. Okay, and see again on the extender. Yes, we have one associated device. We have one active device, and let's see MAC address of this device to make sure it is the Wi-Fi client. Okay, yep. We have this MAC address of Wi-Fi client. Yes, and here is it. Yeah, we have Wi-Fi client connected to the extender. And next thing, and the last thing here, let's run a DHCP client to get IP address. And here, to be sure that we receive this request on the gateway, let's run TCP dump on the Berlan bridge of the gateway. Okay, and start. Yes, and here we see that we receive IP address from the gateway. Yes, and we receive this, and we see this DHCP request and DHCP lease from the gateway to the client. And the last thing I want to show is how the extender connected to the ACS. Because we are running out of time. First thing, let's see on the gateway that we have configured DHCP option 125. Yes, yes. This is the option, and this is the value, which encodes ACS URL. Let's see it here on the extender. Yes, and now let's return to here. This is, I already opened the ACS. ACS, yes, and let's see serial number of serial number of this extender, and this is the serial number that we see in the ACS. So this is the data model of the extender. Yep. For example, we see here DHCP v4 and DHCP v6 only clients, no servers. And we have one bridge here. This is all from my side. Thank you for listening. And now I think this is time for question and answers. Jason?
Yes. Okay. Let me just bring this up real quick.
Yes. Okay. I see five questions.
Yes.
Yeah.
And it's some have been answered on text, but I think some of them we might want to do out loud just so everybody can sort of get the answers to them. But go ahead and look at the ones that you have there. I would think that one of a couple of the big ones. Does prplMesh work with non-prplMesh solutions like standard EasyMesh? And if yes, what agent? Well, you don't have to answer which devices you used for the test, but whether or not this will work with other like with standard EasyMesh as well is probably a good thing to clarify.
Okay. So Jason, we can start with the questions. Yeah.
Yeah. So the first one that I kind of zeroed in on was does prplMesh work with non-prplMesh solutions like standard EasyMesh devices?
Yes. Here I ask someone from my colleagues to help me to answer these questions. Roman or Nikolai, can you help me with this?
Yes, of course. So prplMesh implementation, as developed in Purple Foundation, passed certification from Wi-Fi Alliance, and it's ready to work with non-prplMesh solutions.
Great. And there was one that was answered on text, but I think that people should probably hear the answer. How do you manage the firmware of the minimal extender since there's no management protocols? And Nikolai, you had already written an answer here. I'll let you say it out loud, or I can read it off for you.
But yes, I can repeat it aloud. For a minimal profile, there is no configuration from ISP side, but all extender devices was designed to have IP address from LAN network, and OEMs which would adapt can provide the standard way to update firmware from user side.
And similarly, when using LCM on the extenders, there was a question about using USP directly on the extender such to do LCM management. That's the idea.
Yes, for LCM devices, basically LCM can work only when you use either USP or TR69 management and control which LCM application will be installed from ISP server.
Okay. All right, I'll let you guys look through the rest of the questions. I see there's a question about using Wi-Fi.radio versus the data element section of the data model. And that's a big topic, but I wonder what you guys' answer is to that question.
Yes, it's a huge topic. Basically, most part of data elements provide as read-only objects, and they have no conflict with device Wi-Fi radio configuration. They have writable paths for mesh-specific information, for mesh-specific statistics, and for mesh-specific configuration about what and where should be reconnected, but writable paths about access point configuration, about radio configuration is mostly on device Wi-Fi radio.
And I can answer that a little bit too on the USP side. The reason why those things do seem replicated is because in working with WFA and including data elements in the data model, there was a goal to make sure that it mapped perfectly with what they had done, so that everybody would know, everybody who understood that way of managing things would be managing it that way. Yeah. Oh, Ramon, I see you're typing an answer here, but if you want to answer it live, do you recommend setting the ACS URL from DHCP, or can it be set from the firmware?
Yeah, I find one simple question which I can answer faster. So yes, you can. There is a possibility to set default ACS URL before you build your firmware, and in this case, you can use this URL.
All right. Oh, does prplMesh use the same map controller and agents as EasyMesh? Like, can you use map CLI commands?
Jason, I can't see these questions. I'm slightly lost here.
If you open the Q&A control panel, and if you don't see it,
yes,
say more. Yeah.
Yes, I have it opened.
This one is scroll. If you scroll down to the bottom,
okay,
there's
yeah.
one. Yeah. Does prplMesh use the same map controller and agents as EasyMesh?
Oh, sorry. Oh, sorry. This prplMesh is the same map and agents as EasyMesh.
Yep.
Okay, actually, good questions. We can answer this question after the webinar. Or I see it's already answered. Or no?
Oh, no, I was just clicking that you were about to answer it live. But for that person who asked that question, if you are asking them anonymously, we can't follow up with you after, just so you know. Okay. Any others of these that you guys would like to grab?
Let me see.
We can answer on the question, what is workflow to configure Wi-Fi IP or AP on extender? ICS, you speed up it via TR 069 or TR 369 connection to extender. OSP, USP configure Wi-Fi AP on prplMesh controller and deploy Wi-Fi AP. Oh, stop. Where is this question? For some reason, anyway, yes, the workflow the following. You configure all necessary settings for Wi-Fi IP on the controller side, and if you have connected extenders device successfully connected, so which establish a connection, prplMesh connection, all settings will be redeployed to the extenders device. Yeah, I found this question. Okay.
There's two questions about onboarding, so maybe we can cover that all at once. How does onboarding of the repeater happen? Do you have a standard IP address, or do you rely on DHCP? And then somebody else asked, what are the onboarding mechanisms other than WPS?
Okay, there is no standard IP address. Yeah, here we rely on DHCP server to provide the IP address to the repeater, to the extender. And also, I saw here a question about STP, but now
yeah, it's under.
Yes, I see it. Yes. Could there be newer, more lightweight protocols to use instead of STP? And I have a question here to this person. What are examples of lightweight protocols? Yes, it can be considered, of course, but what are examples?
And the choice of the use of that protocol, I'm not familiar with it, but the choice of the use of that's in the prplMesh implementation, or is that something that was decided higher level than that? Like, if our answer to them is, that's a great idea, why don't you contribute it? Then
And the next question from Ivan Pena. Do you recommend setting the ACS URL from DHCP? Okay, actually, or can the ACS URL be set from the prplOS firmware build? Of course, ACS URL.
I think I have already answered on this question.
Yes. Okay, but okay, it's not marked as answered. Or am I wrong?
Yeah, you're right.
Go ahead. Yeah, go ahead.
I mark it.
How about currently the extender is onboarded to a gateway via the Ethernet backhaul. Is it possible to onboard to the gateway via wireless backhaul with the Freedom board running an image based on the extender profiles?
Yes, I'm trying to find this question.
I will help you. Yes, we can. Works both method via Ethernet or via Wi-Fi, no matter. That's it. Next question from Ivan Piana. To set the parameters for MQTT from the build, do you have a guide or some reference to achieve using prplOS? Yes, it is all necessary documentation added to our components, which provide necessary functionality, how you can make it. Basically, it's configured on prpl profile site. You can change necessary options and get what you want. Okay, about the question about DHCPv6, does it support setting DHCPv6 stateful and or DHCPv6 stainless? I think Nikolai's, both of you, I need help with answer on this question.
Sorry, I was basically, yes, it support setting both stateful and stateless for IPv6 address configuration, you can use even Slack configuration, and for server provisioning, servers provisioned according to USP and TR69 standards. Both of them can work in stateless mode because options required for provisioning is under vendor-specific option and doesn't require stateful mode.
Okay, next one. How does steering work with non-prpl agents? I mean, for STA, which are connected behind mesh agents, which is not prpl based. Also not sure about this part. Guys.
Sorry, Roman, I missed the question.
How does steering works with non-prpl mesh agents? I mean, for STA, which are connected behind mesh agents, which is not prpl based.
Yeah.
Actually, okay. Here we rely on prplMesh functionality. Since in the extender we do not add new features, so here we rely on what prplMesh agent already has. Okay, if it
and the prplMesh agent implements steering based on IEEE 802.11v standard with 11v messages.
Second.
Okay, next question. I see have seen simple loop detection based on sending special packets. I think this is the answer to my questions of some examples of lightweight protocols. Actually, STP is does the same thing. It sends a special packet and detect if the same packet is received back on probably on other port. And STP is already supported in Linux. It's a standard thing.
All right. Thank you, everybody. That is like a lot of questions, which makes for good webinars. So we appreciate that. If we haven't had an answer to your question, unless you asked anonymously, we'll be able to follow up with you after, and also make sure that you consented to be contacted. And along those lines, we will have the video and slides made available to those who did consent to be contacted. If you are on this webinar not a prpl member and want to be able to contribute to this work, and have your opinions heard and put into the solutions, please do join the prpl Foundation. You can find more information there. If you are looking to get prpl certified, you can see the current certification list and a full description of how to get certified at that link right there. And before we go, I do want to mention, do join us in October. It's actually a couple weeks away now, at the Global prpl Summit 2025. That will be in Paris on the 13th and 14th of October and runs right before Network X. So if you're here for one, you can go to the other. And we'll be covering an awful lot of topics. There's the first day is the business day and has a lot of high-level conversations about prpl deployments and how things are working and what the future looks like. And then Tuesday is Tech Day, where we'll be having a lot of conversations like this, and some presentations about how things work and where the roadmap is going and stuff like that. All right. Thank you guys very much for putting this together for us. And do look forward to our next webinar, probably in a couple months after after NetworkX and after the summit and after all that chaos has gone down. But please do look out for more announcements on more webinars, and we will talk to you all soon.
Thank you very much.
Yep, thank you all.
Thank you, guys.
Bye.